Can you see the TV screen on
I can see the I can see the TV screen.
Yep, I see your screen, but why isn't it sharing? Let's see here. Stop share.
There we go.
Share screen 2.
Okay, I can see it now.
There we go.
Okay. Now you got it? Okay.
Yes, sir.
Come on. Worked fine before. What's the problem now? There we go. All right, so here's a picture of a basic air sensing thermostat. This style, you typically only really see in smaller units. You do see a few of them out there in, commercial walk-ins and stuff like that, but not very commonly. The ones we typically see are like the Penn or the Johnson or the White Rogers, These work the same way. They're just set up a little different. They have a cut-in temperature and a differential. Now, the switch low event, which is the cut out, is the high event minus the differential. So your cut in, this one's set at, looks like it's set at 40, and the differential is set for 5. So the cut in minus the differential equals the cut out. So what it'll do is it'll cut in at 40. So once the temperature gets up to 40, it'll close and open your solenoid. And once it gets down to 35, it'll open that switch and disengage the solenoid, and then therefore pump down your compressor and all that good stuff.
And that's saying that the box is at 35 degrees?
Right. So the 35 is the low event. So once the box gets down to 35, this will open back up and close your solenoid valve.
Okay, so that 35 is box temperature.
Well, yeah, that's the low event. That's the cutout. So once the box gets down to 35, it'll open. Once the box gets up to 40, it'll close. So it's got a 5-degree swing. Adjusting your commercial thermostat, you set the cut-in temperature first, or your high event, then you set your differential, and that gives you what your cutout is, your cut-in minus differential. An air sensing thermostat, again, here shows you kind of the slider, how they're setting it. Set that to 40 first, and then set your differential down to 5. And that gives you a 35-degree low event. So the box won't go below 35. This is a little diagram just kind of showing you the temperature swing. Goes from 40 down to 35, cuts out. And it's going to show you your evaporator temperature. Your evaporator temperature is usually about 20 degrees colder, 15, 20, something like that. Evaporator temperature drops with the space temperature. For an off-cycle defrost, it's typically what they use in medium temp, 35 to 40. When your compressor is running, the coil temperature is below freezing, remember, because it's 15 to 20 degrees lower than the box temp. So therefore, frost begins to build. And when the compressor cycles off, in an off-cycle defrost, your fans will stay on, circulating the air through the coil. The coil rises above 32, and the frost will start to melt. This just shows you that same diagram we were looking at with the defrost side added onto it. 32 is the frost line. Below that, the coil will frost, compressor shuts off, temperature will come up. Typically to about 40 to 45 degrees before the timeout, and then it will resume refrigeration. Another style is a coil temperature sensing thermostat. The Tstat bulb is mounted in the evaporator fins, responds to the evaporator temperature, not the air temperature. Coil temperature drops as box cools, because there's less heat to remove, or less heat in the box. frost forms on your tubing, the Tstat shuts off the compressor, and the compressor stays off until the coil is defrosted. The primary advantage of coil sensing Tstats is it allows the coil to completely defrost before the compressor starts. And you know why they say that, why it allows it to completely defrost? Because with that bulb shoved in the coil, it's sensing the temperature of that coil, just like it shows right here. And, you know, it's not going to close again until the coil's warm enough and there won't be any frost left on it. They are nice for that. You'll see this, not this exact style, you'll see some similar to this in a lot of our prep tables, condiment bars, that kind of stuff. We see it in, you know, C-stores and whatnot. Typically they're set pretty, you know, there's not really any adjustments you can make for the most part, other than just changing the temperature. The differential is usually preset in this style. This one, for instance, has got a 35-degree cut in and a 20-degree cut out. So once that coil gets down to 20 degrees, it's going to open that back up, shut your and close your solenoid. A constant cut-in thermostat has a factory cut-in temperature, but it's an adjustable cutout to match your system TD. Maintains your box temperature, and when the customer goes in and starts messing with that dial, turning it up and down, it's not going to cause icing issues because the low event is already set, you know, from the manufacturer. They do have an adjustment screw on some of them to change for altitude. So if you're in, you know, a higher altitude or a lower, you need to make sure you watch for that. Altitude changes the pressure in that thermostat. And if you don't adjust that for your location, you can have some issues. This one right here, this is one of the ones I was talking about. This is the most common one you'll see. On the back of this, there is an adjustment screw for altitude.
How do you find out our altitude?
How do you find out your altitude?
Yeah, we have to
Google.
set it.
Yeah, I would just Google it. Just Google what's the altitude in, you know, whatever city you're in.
Okay. Let me find that out right now.
You have electronic thermostats. They're a lot more accurate than electromechanical. A wider application and temperature ranges. You can use them for anything. Because you can set them for anything. One of the most common ones we see is this Ranco one right here. You know, these have a programmable differential in them. You can set them for. Some of them have a programmable defrost in them too. If you're just doing an off cycle, you can set that up in here. These ones are pretty nice. One thing I will say about these thermistors is if you're ever wanting to check the accuracy of them to see if they're, you know, right, if it's reading what it is, if it's saying the correct temperature on it, you can take that thermistor and go get you a cup of ice, fill it all the way to the top with ice, and then with cold water, stir it around and stick that thermistor like right in the ice, and it should be pretty close to 32, within a degree up or down. If it's way off, you've got a bad thermistor. And at that point, you just replace the whole thing. I have had guys in the past replace this thermistor with just a regular like green lead sensor. And they're two totally different things. The green lead sensors are a 10K sensor. They're kind of a fixed thing. Whereas this thermistor is, what was it? I think these ones are more like a 35 or 40K. So make sure we don't use those. If you're trying to troubleshoot that, just replace the whole thing. Pressure controls, they stop and start the electrical current flow, energize or de-energize refrigeration components, switching the arrangement of pressure controls. You have two different types. You have an open on fall, which is your low pressure, your low ambient fan control, or an oil safety switch. An opens on rise would be a high pressure safety control. Another control it's kind of off subject, but it's not a pressure control, but something like a defrost termination, whether it be a clicks on or those little Ranco ones you see in the end of a freezer coil. Those are an open on rise. If it's a 3-wire clicks on, it's also a closes on fall because they use it as a fan delay. So it'll open once the coil gets up to a certain temperature, send that signal back up to your defrost clock to tell it to, defrost is over. And then once the coil gets down cold enough to a certain temperature, it will close and give power back to the fans. That's what those the 3-wire clicks-ons do. It does both. It does a defrost termination and a fan delay for you.
Oh,
So low pressure control, when the pressure falls, the switch opens. So adjusting it, you adjust it just like that one temperature control. You set your cut-in pressure, you set your differential. The cut-out is your cut-in minus your differential. So if you take a look, yep, shows it right here. So this next slide, they've got this one set up for 30 on the high event and 10 on your differential. So what would be your cutout on that? What pressure is this thing going to shut the compressor off at?
you say is that 30? Is that 20? Then 20?
It would be 20, correct. Yep. So it's your cutout, or your cut in is 30 and your differential is 10. So if you take your cut in or your cutout minus your, cut in minus your differential, that gives you your cut out. So when that solenoid closes and that compressor starts to pump down, once that unit gets down to 20 PSI, it's going to kill power to the contactor and shut the compressor off. Now, these aren't always 100% accurate. So if you're installing a new one or if you have an issue with one and you want to know if it's working correctly, the best way is to gauge up on your low side and then either valve off your receiver or your liquid line and pump it down and actually look at your gauges and see what the compressor is shutting off at. You want to make sure it's accurate, and you want to do it a few times to make sure it's the same every time. If it's shutting off at 20 pounds and then the next time it shuts off at 15, the next time it shuts off at 25, you've got a bad pressure control, replace it. Now, if it's shutting off at 15 on your gauges, but here it should be shutting off at 20, but it's shutting off at 15 on your gauges every time, that's fine. It's just this thing's a little off. So don't worry about that. A lot of these low pressure controls in this style, if you look over on the left side underneath this spring, you can take your service screwdriver and stick it in there. And you can actually do this instead of pushing in the contactor if you're trying to pump down a unit. Sorry, hang on here, guys. So you can use this to pump down your compressor instead. Just by prying that up with a little screwdriver, you just stick it right underneath that little spring and just pop it up a little bit. It's another good way to easily tell if it is your low pressure control that's holding your compressor out or if it's something else. This will show you a diagram of the low pressure control, setting it. You want to set the cut in for 30, differential to 20. That's going to give you, let's see, that's going to give you a 10 PSI for the cutout. Setting your low pressure controls, you want to follow your manufacturer recommendations. If your cutout's too low, if you're pulling down into a vacuum or trying to pull it down to 0, when that compressor is not designed to do that, you can overheat your compressor and cause some damage. If your differential's too close, and it's going to cause some short cycling. You know, if you only have a 5-degree or a 5-pound swing, that compressor is going to turn on and off a whole bunch of times while it's in a defrost or while it's satisfied on temperature, just because you have that too close. Outdoor units are affected by low ambient. The cut-in must be just above your lowest ambient. So another thing you could go to Google for, just Google what's the lowest ambient in Salt Lake City or Phoenix or wherever, and you want to kind of go off of that. Every low pressure control new in the box comes with one of these. If you don't have one, they're easy to find online. This is going to show you an example if for 404 medium temp walk-in with a lowest winter ambient is 10 degrees above, positive 10. So you're going to set that with your low pressure control at 40 PSI cut in and a 20 PSI cut out. For indoor, you want to go with 30 degree lowest ambient, just because that's the highest one there is on there. A fixed low pressure control or an encapsulated one, no adjustment on the control. The manufacturer doesn't want it changed. It's just set for whatever it is. The only way to test these is to just take the wires off of wherever they go to and test them for continuity. If you get continuity, that means it's closed and that's not your problem. They're preset. Like I said, no adjustments can be made. It's just, it is what it is. I personally don't like these ones. If you have to replace it, if you have a bad one, I would go get a mechanical one. Unless you have one of these on your van, then go for it. You can use low pressure controls also to control temperature, because in our business, pressure is temperature. Used on some indoor reach-in refrigerators. You want to check with your manufacturer for the settings, but the general rule of thumb, a control cut-in would be at a pressure equal to the desired box temp.
And that's only if we don't have a stat on the truck and we just use that just to control the temperature for the time being.
No, you only want to do this on indoor units. If it doesn't already have this type of control set up, don't add it. But if some units use this to control their temperature, not very many, it's not very common.
When you say control, you saying self-contained?
Yeah, self-contained little stuff like little, one-door reach-in fridges or something like that is typically what you
no split. Okay.
Yeah. It works kind of the same way. It's just using pressure instead of temperature. So at 33 PSI on 134, you're going to have 38 degree box temp. Evaporator temp is going to be quite a bit lower, obviously. 12 PSI would give you a 10 degree evaporator. When the compressor shuts off, same thing, it just goes off of the pressure. Once the pressure gets up, it'll kick it back on. Not very common, but they are out there. Benefits of using a low pressure control for temperature: one control, three functions. Controls the box temp, ensures proper defrost, and it's a low pressure safety for the compressor. Your high pressure control opens the compressor circuit on pressure rise. So setting your control cutout, you want to check with the manufacturer, or your rule of thumb is 155 degree condensing temperature. So R134, you'd be at 283 cutout, R22, you'd be 382, 404, you'd be 427. But this is also very susceptible to where you live. Now up here, typically for 404, we have our high pressure safety cutout set for about 350 to 375. Now down in Phoenix and Vegas, where you guys are at, your temperatures are going to get a lot higher. So your pressures are going to be more in the 400 range. High pressure controls, some of them have a manual reset, most are automatic. Typically they only have one slider on. If it's just a high pressure cutout, they don't have a slider for the differential. You set it where you want it, and that's it. You can test these things same way you test the low pressure, gauge up to your high side, either disable your condenser fan motor, or you can take the top off of the unit and cover up the condenser to raise the pressure also. If it's the middle of summer and it's 120 degrees outside, don't worry about it. Just set it where you think it should be, 350, 375, 400, and call it good. We don't want to try to raise the pressure when the temperature's already hot as hell outside. It's just causing unnecessary stress on the compressor. Most of the automatic reset ones have a 50 PSI swing in them. So if I have my high pressure cutout set at 350, the automatic reset is not going to kick in until it gets down to 300. Here we have a dual pressure. It's the same thing. It's just both of them together. So you have your high pressure slider over here. You have your low pressure with your cut in and your differential here. And if you see these like this and you don't see the instructions on how to set them, you just pull the cover off, and it's usually printed just like right below right here. It'll tell you, cut in or cut out is cut in minus differential or whatever, however they have it set up. There's a couple different ways. Obviously, we want to go off the PSI side, not the bar. Low ambient is when your condensing temperature drops below 90. Why don't we want low ambient? It lowers your condensing pressure. Low liquid pressure affects your metering device. You get flashing, you get starving evaporator, it can cause icing issues. If it's flashing out of your metering device, whether it be a TXV or a cap tube or something like that, the solution is to use a head pressure control, whether it be a headmaster or a fan cycling control. Dampers are an option. You don't really see those though. Flooding, we'll cover that on a later topic, flooded condensers. Fan cycle controls is a pressure switch that controls the condenser fan. When the head pressure falls, the fan shuts off. When the head pressure rises, the fan starts. So instead of using a headmaster, we're more, in most applications, you can actually use both, but typically you see one or the other. So when the head pressure starts to get too low, it'll cut the power to that fan to try to bring it up. And once it gets up high enough to where we want it, it'll give power back to that fan. Everybody following along with that? Understand how they work?
Mm-hmm.
Now, a fan cycle control and a head pressure control are two totally different things. One closes on rise, one opens on rise. You need to make very sure if you're replacing one or if you're going to install one. If you're getting it for fan cycle control, you want it to open on the fall. So that would be a close on rise. So when the pressure goes up, you want it to close so your fan will come on. If you put a high pressure control in there, it's going to do the exact opposite. When that pressure gets higher, it's going to cut power to your fan. And you'll be back there real quick. Adjusting a fan cycle control is just like adjusting the others. You just got to know what you're dealing with, what kind of gas it is, what proper condensing temperatures and pressures are, what you want it to be set at. Your high event cut in for R22, 225 or 110 degrees, and your low event is 170 or 90. That's the goal where we want to keep our condenser. It doesn't always happen that way, but that's what we'd like it to be. Everything we can do to help that is beneficial. Dampers for head pressure control, it's essentially like I was just talking, you can take the cover off of the unit and cover up your condenser. It's the same thing. These are just automatic ones. This little diagram right here. So these little things right here, when the head pressure gets too low, they'll turn and close. The fan stays on. This will just close and restrict that airflow. You don't really see these though. I think I've only seen one, and it was not in operation. It was at an old shop. You guys, what about you, Selvin, or anybody else out there? Have you seen one of these before or dealt with one?
Now that I think
I've never
about it,
seen one.
Yeah. They're not really common. They don't make them anymore. They're not doing this anymore. Nowadays, things are going to modulation. They're changing to, instead of turning things off and on or a fan cycle control or dampers, they're doing variable speed motors or ECM motors. So what was that?
I think it's too hot here in Arizona for those.
Yeah, I bet. A VFD or a variable frequency drive is what they're using now. They'll speed up and slow down the condenser fan motor instead of starting and stopping it for two reasons. It's a lot better for the motor, a lot less wear and tear. It's a lot easier for it to slow down and speed up than it is to start and stop, and energy consumption. Uses a hell of a lot less power to just speed it up a little bit than it does to start a motor, especially some of these big ones you get, where the fan's like a 2.5 foot diameter fan blade. So we'll kind of skip through this one just because we don't really deal with them. Oil pressure safety control protects your compressor from lack of lubrication. Operates on a pressure differential between the oil pump pressure and the suction pressure. So the outlet pressure of your oil pump and the suction pressure inside the crankcase, also called your crankcase pressure. For an example, if you gauge up to your oil pump and you have 50 PSI right there and you have a 20 PSI suction, that gives you a 30 PSI net or oil net. You want to make sure it's always above 10. Really, 30 to 40 is the good range. So anytime you're working on a compressor rack or something, and you call Jim or me or Eric or Selvin or whoever for help, that's probably going to be one of the first things they ask you if you're dealing with oil problems is what's your oil net. The easiest way to check that, you see this is your oil pump here on the front of the compressor. And right here you have a little T coming off. Now, one of these right here has a straighter, the other does not. Just loosen the cap a little bit. It's usually this one that doesn't. You just take that cap off, hook up your low side gauge to it, hook up your other gauge to the back side of the compressor on the suction, and you should have at least a 10-pound difference between the two. This should be at least 10 pounds higher than your suction pressure. You really want it to be more like 30.
Okay, so pump oil pressure should be higher than suction pressure at all times.
Right. Yep.
On the on a rack on a compressor. Okay.
Correct. And if your oil, the reason we check the oil net, because it tells you quite a few things right off the bat. It tells you if the pump is turning, for one, and then it also tells you if you have a plugged inlet screen on pickup screen in the bottom of the compressor, or on the oil pot. This one doesn't have a picture of it, but usually on this side or on the other side, you'll have a little oil pot with a float in it based on, the level of that float. It opens and closes and lets more oil into the compressor.
There's also box they have on the side.
Right. Yep. There's also another screen in the inlet side of it that can get plugged as well. So a couple easy things to check. And you can pretty much tell which one it is just by checking your oil net. These oil pressure controls are a little outdated. They're not really around. On some older stores, you might see them. This is typically the one we see right here is the Centronic or the Centronic 2. There's a couple different variations, but you'll see this big brass nut sitting right. Let's see, go back to the compressor. you'll see a big brass nut poking out of the side of the oil pump, like right about where that T is, just below it. And that's called a sender. That takes the pressure between the oil pump and the body of the compressor. So that does everything that other one's doing just right here. And they have a push to reset. If you show up to a store and you have a compressor off on oil fail, do not push the button. You got to check some things out first. If you just go in there and push the button and that compressor's been off for 3 or 4 hours and the valve's still open and it's just dumping liquid into that body, as soon as you push that button, the compressor's going to start up. And if that crankcase is full of liquid, you're going to grenade that thing. Break all kinds of stuff inside, valves, the crankshaft, anything. Just liquid is bad for compressors. If your net oil pressure drops below 10 psi, there's contacts inside that Centronic that close to start a timer. And if that timer if that low pressure continues for the length of the timer, 120 seconds, the control circuit will open. That stops your compressor, and it closes an alarm contact. Whatever you're dealing with, whether it's CPC or microthermal or Novar or whatever control system it is, they all do the same thing. It just has a little contact in there that closes when that timer times out and sends an alarm signal out to tell you have an oil fail. An oil fail on one compressor is not really going to affect much on a big rack system. But if you have multiple compressors going off on oil fail, those are some of the hardest problems to diagnose is oil issues. This just kind of shows you a little diagram of how it works on the inside. Pressure gets low, contact closes, starts the time. If the timer times out, contacts open here, kills your compressor. Compressor shuts down, alarm contacts close, the alarm goes off. A lot of nuisance trips on oil fails are due to brownouts or low voltage, or you lose a leg or something like that in there. Compressor will go off on internal overload, but the oil safety control still has voltage. Control times out and trips is because the compressor is off and there is no oil pressure. The way to stop that is there's a current relay or a CT or whatever you want to call them that can be installed with the Centronic. You run one wire of the compressor through it. As long as it's drawing amperage, it closes some contacts. You wire that in with your there. It's not going to get to that slide for a second. There we go. So you wire it in right here. Goes in with your pressure leg. So it's got the oil pressure control here. If that closes because there's no pressure, the CSR senses the current, so the contacts remain closed. If it doesn't sense the current, let's see. Come on. Off on overload, no oil pressure, contacts close, and no current, then these contacts will open and let it start the time. So it does away with a lot of the dumb calls where they just had like a power bump or an outage or something, and you have to go in and reset all these oil safeties because they tripped. Let's see, we got some time. Not really. All these slides are available, or they will be, on the website. You can go through the review questions on your own or as a group if you'd like to. We just don't have enough time. We only have an hour allotted for each class. So, would you guys like the link to these questions, or what do you think?
Yeah.
Let's get it so the guys can take and can review.
Okay. I'll make sure Nick gets those sent out to all the branches, all the service managers. and then they can funnel them out from there.
Perfect.
So, all right, guys. Tomorrow will be Jim Alexander teaching. He's doing a specialty class. I'm not sure what piece of equipment, but his class is focusing on one specific piece of equipment every week. So be sure to tune in.
Thank you.
Sounds good. Thank you.
Thanks, guys. Have a good day.
You too.
Yep.
See ya.
Yeah.